Hello, hi, Assalamualaikum. Today we will proceed with the chapter 6, fluid storage and the conditioning. For this chapter 6.1, it is divided into the three subtopics. First, reservoir. Second, filters and the strainer, and also the third one is the heat exchangers. Okay, for the reservoir, as you can see here, this figure shows the reservoir. The proper design of the suitable reservoir for the hydraulic system is essential to the overall performance and the life of the individual components. The reservoir is served not only as a storage space for the hydraulic fluid used by the system, but also as the principal location where the fluid is conditioned. So, the primary purpose of the reservoir is to hold the system fluid while currently used in the system. Okay, to hold and to store the fluid. Other important purpose of the reservoirs are first to remove heat. Okay, to remove heat. So as you can see here, it can promote the heat dissipation through the reservoir wall and also to the surface. The other purpose of the reservoirs to separate the solid particle. So we can separate the solid particle here, remove the dirt particle, release air from the fluid. So as you can see here, remove the entrant air, and then also separate the water from the fluid. The purpose of the reservoir. For the sizing of the reservoir, the sizing of the reservoir is based on the following criteria. First, it must make the allowance for the dirt and chip to settle and for air to escape. Second, it must be able to hold the oil that might drain into the reservoir from the system. Third, it must maintain the high oil level to prevent air drawn into the pump. Also, it should have a large surface to dissipate heat generated by the system. And the last one, it should have the space to allow for the thermal expansion of the oil. So in the general practice, reservoir is the 3 times of the volume, the rates. Next is for the filter and strainers. Okay. Fluid conditioning devices provide fluid that is clean and maintained at an acceptable operating temperature. So, most hydraulic system failures are caused by the fluid which has been contaminated. Okay, hydraulic fluid which has contaminated reduce the ability to first is to provide lubrication to the component. Okay, it's reduce the ability of the fluid to provide the lubrication to the entire system, and then reduce the fluid ability to seal the clearance between the parts. Okay, and also it's reduce the ability of the fluid to transfer heat and also the transfer energy. So this will lead to the increase of the wear, because of the friction, due to the lack of the lubrication, and also increase the part clearance and loss of the system operating efficiency. So the best way to assure the clean operating system is by preventing contaminant from entering the hydraulic system. So that's why we need to use the strainers and filter. Okay, so the strainers and filter usually used to remove the contaminants by trapping insoluble material contained by the hydraulic fluid. Okay, strainers are generally considered coarse filter designed to remove only the large particles. Okay, strainers are constructed of a wire screen. They are rarely contain opening less than 100 mesh. And for the filters, are generally considered fine filter that can remove the small particles. Okay, There are three basic types of the filtering method. First is the mechanical. Okay, this type normally contains a metal or cloth screen or a series of the metal is separated by the thin spaces. Many mechanical filter types are capable of removing and only relatively coarse particles. Okay, next is absorbent. Absorbent is filters that are porous and permeable materials such as paper, wood pulp, cellulose, and also the asbestos. In this type of the filter, the particles are usually absorbed as the fluid permeates the material. As a result, these filters are used for extremely small particles, or we can call it very fine particles. For the absorbent is a surface phenomenon where the particles have a tendency to cling to the surface of the filter. Thus, the capacity of the filter depends on the amount of the surface area available. Absorbent material used includes the activated clay and also the chemically treated paper. Okay, next we proceed to the different type of the placement. So as you can see here, we have the 4 different type of the filter placement. The first is the proportional flow filter in the separate drain line. So we put here. Okay, full flow filter in the pressure line here. Okay, full flow filter in the suction line here, and full flow filter in the return line. So here. For the proportional flow filter in the separate drain line, the primary disadvantages of this filter placement is there is no positive protection of any specific component within the system, and there is no way to know when the filter is ready. Okay, so for the full flow filters in the pressure line, okay, this type of the filter placement is normally used in the system where the high pressure components such as valves are more dirt sensitive than the pump. Okay, the pressure line filter are actually designed to sustain the system operating pressure. For the flow filter in the suction line, this is this one is the for to filter the contaminant before entering the system, and for the full flow filter return line, this one are used in the system that do not have a very large reservoir to permit contaminant to settle to the bottom. Okay. Actually, in the general, there is no best single place to put the filter. Okay, we can consider where data enter the system and put the filter where they are do most good. Okay,